Welcome back to B Spice. In this session, in gas detection technologies, we'll focus on electrochemical oxygen measurement. So, if you're a first time viewer who wanted to inform that as part of this gas detection technologies, we have uploaded few videos on catalytic bead, metal oxide semiconductor, non-dispersive infrared open path and non-dispersive infrared point type, and tunable laser diode absorption spectroscopy, and photoacoustic infrared and electrochemical toxic. And this is all about electrochemical oxygen. So this is the look and feel which we'll be dealing in detail in the subsequent slides. So when we talk about the electrochemical, yes, it's electrochemical technology measured or used for oxygen measurement, right? So what type of gas detected? Yes, it's oxygen deficiency and enrichment. So it's more about oxygen. Okay. Then what's the principle of operation? Again, it uses the same electrochemical reaction to generate a current proportional to the gas concentration, similar to the electrochemical toxic. The sensor is a chamber. Okay, when we talk about this, description, the sensor is a chamber. There is a bit of difference from, electrochemical toxic. Yes, I'll tell you that. So the sensor is a chamber containing a gel or electrolyte and two electrodes. I'm not sure whether it is visible, friends. I'll just blow up a bit. Yeah, I think now it's good to go, right? Yes. Yes. Okay. Maybe a little bit more. Yeah. Okay. So the sensor is a chamber containing a gel or electrolyte. As you can see here, the white one, right? Electrolyte. And two electrodes. You can see here, right? The measuring electrode. That is, what do you call? This is the measuring electrode, gold or silver working electrode. This is a cathode, right? Then we have the counter electrode. That's the, a reference electrode, anode actually. Okay. So this is usually lead basically. Yeah? This is the lead. And see now, if you see the, the difference, friends, with the like what do you call the previous one electrochemical toxic, there are three electrodes, right? Here only two, anode and cathode, that's it. Okay, right. So coming back to the subject here, the gas sample enters the casing through the membrane, right? Oxidation occurs at the anode here, right? Oxidation occurs at the anode and reduction takes place at the cathode. When the positive ions flow to the cathode and the negative ions flow to the anode, a current proportional to the gas concentration is generated. That's all about the principle. So by contrast, the electrocatalytic system in a XL, that is the one, this one, right? This one. So this XL type, which I'm going to talk in the next slide, is a lead free, that is not lead, okay, and uses a non-consuming chemical reaction, which I will also explain. Thereby, it's eliminate the susceptibility to shelf life limitation. If you have a lead, you have the challenge, having a shelf life. But this guy, the lead free type, it eliminates that. Okay, that's the point. Okay. Now, how the measurement reading? Yes, percentage by volume of oxygen. And when we talk about the pros, yes, very high sensitivity, linear output, easy to handle, not subject to poisoning. Excellent pros. And when we talk about the cons, limited shelf life, I'm talking about this, friends, not the Excel. I'm talking about this. Limited shelf life, subject to interference, sensor life shortened in very dry and hot environment. Yes, that is for the lead type actually. Okay. Sensor life negatively affected in enriched oxygen application. This is all about the, what do you call the lead type, electrochemical oxygen lead type. Okay. Now I will go and explain the one, the advanced Excel one. Okay, friends. Right. Let's go blow up a bit. Yes. Okay. I think it's enough, right? Yes. See, the same type of sensing electrode, reference electrode, but the the look and feel, the physical look and feel is different. Okay, then you have the counter electrode here. Okay, so the reference electrode is here, you have the counter electrode. It's similar to the toxic one, what we have covered, right? Sensing electrode, reference electrode, counter electrode. And you have the circuit board, all these are there. The main point is here, friend, you see this, non-consuming reaction. See here, this blue is oxygen, right? So this color, I think, what is this, yellow, is a hydrogen ion, H plus, and this guy is a hydrogen, H. Okay, then you have the what do you call, gray actually. So this is electrode, electron actually. So this diagram illustrates that for every oxygen molecule that is reduced at the working electrode, as you can see here, for every oxygen molecule, okay, reduced at the working electrode, that is a cathode, okay, a complementary oxygen molecule is produced by the oxidation of water. A complementary molecule is produced by the what do you call, oxidation of water from the electrolyte at the counter electrode, which is the anode actually. Okay, for every, again I repeat friends, for every oxygen molecule that reduced at the working electrode, cathode, a complementary oxygen molecule is produced at the oxidation, by the oxidation of water at the counter electrode, that is anode. Okay, this non-consuming process eliminates the sensor life limitation and exclusively associated with that lead based design. So that's about the advantage of having this, friends. Okay, that's all I have for this session. Thank you for watching. See you in the next video. I'll talk about another technology. Thank you. Take care. Bye bye.